Have you ever wondered what a seed looks like from the inside when it's germinating? You might have grown seeds yourself for your garden or sprouted them on the windowsill. It's really easy to grow seeds. You might have hopped down to the health food store and bought some mung beans and alfalfa, take them home, you soak them overnight, 8 or 12 hours, and in the morning you rinse them out, and then you can put them on cotton wool or in a little dish of water. And then over the next few days, what do you observe? You see them swell up, you see a little root come out, you see them split open, and then a leaf emerges, and then you get to eat them. Now, I just want you to think about what you're observing when you watch a seed grow. So it's a very human experience, isn't it? There's a scale. You're bigger than the seed. You're only seeing them with your eyes. You can't look down at it microscopically. And also, you're observing them at certain points of time. So you can't sit there for 3 or 4 days watching the whole process. So today, what I'm going to do is show you a seed germinating from a very different perspective. I'm going to show you the inside and the outside of the seed germinating at the same time. But I'm also going to show you a seed germinating in the 4th and 5th dimension. But to do that, you need your glasses, and I hope you still have them. So I saw a few people fiddling. And if you don't, you might need to share them with a friend. So we won't be wearing them right now. I'll tell you a little bit further on when we're going to put them on, and I'll put them on as a signal. But for now, just hold them in your lap. So we're getting organised. I'll just tell you a little bit about myself. I'm a visual artist, and I'm trained in the traditions of printmaking. So that's lino-cut, lithography, screen printing. And early in the 80s, when I was an art school student, I became really interested in computer graphics because, of course, I was there when computers first came to the art school. None of us had ever used them before. And that led me to really think about the way computers were going to change our world, what was going to happen in digital technology. And I became really interested in how we visualise knowledge, and also about virtual worlds. But this also led me to think about scientific technology, because of course science was really taking on those digital technologies, particularly microscopy. And I've been really inspired by microscopy in my work. And I can show you. Oops. I'll show you my work here, which is I flatbed scanned a little 3 centimetre centipede, which is a toy, and then I photoshopped it so it looked like I had a microscope. And then I printed it out 6 metres long as this large print on an inkjet printer. And it was to give that sense of scale, as if you're looking down the lens of a microscope. But I was just playing. I was pretending to be a scientist. So I decided that really and truly, after all of this work that I'd been doing, I really wanted to use science for real. So I approached the Department of Applied Mathematics at the Australian National University. Now, the Department of Applied Mathematics are leaders in the field of 3D microcomputed X-ray tomography. Now, 3D microcomputed X-ray tomography is a really big mouthful, so I'm going to call it micro-CT for short. I'm going to show you what a micro-CT instrument looks like. They're like big cameras, really. So you've got a filament at one end and an optical board at the other, and X-rays get shot through your little specimen, and it creates an image at the other end. And what that creates is 3-dimensional data, or volumetric data. Now, to give you an idea of what volumetric data is, you're all familiar with CAT scans. You see those 2D images of brains and heads? Well, imagine if you had your whole head from ear to ear CAT scanned with lots and lots and lots of slices, hundreds of slices, and that was all digitised, and all those slices were put in one stack. That means that you'd have 3-dimensional volume data, so it's a 3D data set. And that's what the micro-CT does. It creates this 3D data set. But the difference is it's about 100 times more powerful than a medical CAT scanner. So if you put your brain in there, you'll probably get vaporised. And also the other difference is it goes down to about a resolution of 2 microns. And also it's about scanning really little things, not big things like heads. So to give you an idea of scale, what I have here is a little Slater which is, you'll find them in the garden, and you'll see them under pots. If you lift up a pot, you'll see a little slater moving about, and they are actually terrestrial crustaceans. And when you touch them, they roll up into a tiny ball, and they look a little bit like the Sydney Opera House. You see them with their little backs. So what you're seeing is actually a slater that's been scanned with micro-CT, and I've visualised it with this really amazing program called Drishti, which has also been created at the ANU alongside the micro-CT program. And Drishti is amazing because it's open source software. You don't buy it, you can download it for free on the internet. The only difference is that you can't use it with normal computer-generated imagery. It's actually used for micro-CT data, volumetric data. And as you know, X-rays are always in grayscale, so I've been able to colour this little slater in different colours. And what you can see here is its muscular structure inside. And if you look at the top there, you can actually see its last lunch, which was probably someone's tomato or strawberry. So I was really interested in how to create this work as a visual artist. But what I was interested in, because this is a static object, it might be moving, which is animation only, but it's a static object. What I was interested in is what happens when you add time to three-dimensional data, because that's when it becomes the fourth dimension. So I proposed to the Department of Applied Mathematics to add time to this data, and I proposed to them to scan germinating seeds. So what you have here is little mung beans and alfalfa being X-rayed in the micro-CT. They're growing in a test tube. Now the reason you might be wondering about this, why I'm using mung beans and alfalfa, is because I'm interested in agricultural crops. Because the underlying premise of my work is my interest in, well, how are we going in the future with agriculture, and how are we going to grow our food in the future? And you know, it's been estimated that by 2050 there's going to be 10 billion people on this planet. And that means that we're going to have to quadruple our food yield just to feed those people. So I was wondering as an artist how to make work that kind of reflected my concerns about the future of the planet. But, you know, growing mung beans and alfalfa in the X-ray machine, you know, it's not going to solve the world food shortage or any of those kind of things. And also to start with, you know, no one has ever done this before. No one's ever X-rayed germinating seeds. And so as an artist, let alone a scientist, I was really entering uncharted territory. And for that reason, I've had a lot of deaths. And I'll show you here, this is actually what happens inside the test tube. You know, these seeds are in there and they're really trying to grow, but it's a little bit like global warming in there, you know, it's a mini global warming. It's really hot in there. You can see a little bit of condensation and evaporation on the test tube at the back. And you can see those seeds, they're really trying to grow. So actually what this experiment showed me was that growing seeds in a test tube with micro-CT, it's not easy to grow food or food crops when the climate conditions aren't right, you know. That was a bit of a worry. But actually, you know, even though I had failures in this work, I wasn't succeeding with what I wanted to do, which was to X-ray seed sprouting. The kind of life and death play actually works well too, because, you know, the concerns is about also extinction. You know, 40% of the plants now on this planet are facing imminent extinction. So, you know, because of our excessive activity and our increased activity with lots more people in the world, lots of plants and species with it are really facing challenges. So I wanted to explore with this work how that would show it. But I have had some successes. And what you'll see for the first time is seeds germinating in 3D and 4D. So what you're seeing inside the seed is actually little gas bubbles forming. And those bubbles form when the mung bean is about to split open and the first leaf comes out. That's the cotyledon. And what you can see coming over the top there, that's its roots. And you can see through its roots. So you can see the inside and the outside of the seed at the same time. And you can see the roots moving as they're trying to find somewhere to anchor. As the seed anchors down, it will flip up and then the leaf comes out. But you can also see other little things in there as well, like moisture coming up through the bottom of the seed base, and then you can see the interior of the seed grow as those bubbles start to form. But how is this art? How do I bring this to a gallery? How do I get people to experience this kind of science as an art form? Well, I've been really thinking about that, and there's this amazing movement, and there's research that shows that bringing this kind of work to a gallery space and making it immersive as an immersive installation actually gives people a chance to be self-reflective, to really think about their relationship with nature, even if the nature is prescribed to us through digital means. It makes us think, it gives us a time to become self-reflective, to think about our emotions and what we think about life like this, a phenomena that we don't normally see coming into being. And I've been doing this by using stereoscopic projections. It's like 3D cinema. You might go to the cinema and put those glasses on and you get to see this amazing thing coming out of the screen. So I've been doing this in the gallery, and this gives people an amazing opportunity to sit and reflect and look at and watch something that they've never seen before in the most profound way. And I've been calling this the fifth dimension because it's an individual experience. It's another dimension that's added to that work. So not only do you have the third dimension, which is the data, you have the fourth dimension, which is time, and you have the fifth dimension, which is your individual experience of that work. So today, I'm hoping to give you the fifth dimension, the experience of mung beans sprouting in the fifth dimension. So you're going to have to put your glasses on. Now, what you have is glasses which are split into red and blue. So the red should be on your left. And what I've done is I've created an image which is anaglyphic, so that's split into red and blue. And that should give you a three-dimensional image. Now for some of you today, that might not work because you might have a little stigma in your eye or colour differentiation, but we're all going to give it a go, okay? So what you're going to be watching here in the fifth dimension is mung beans and alfalfa sprouting. And this was taken over a 4-day period. But of course it's been sped up. It's not in real time, so it's in time lapse. So what I'm hoping for my... So what I'm hoping for this work is it gives you a self-reflective space to think about something ordinary, something you probably never notice in your daily life, to be able to contemplate your own time on this planet, your own time on Earth, to contemplate that all life is momentary.